Section 1.3, more about limits. The first part of the section, if you look in the textbook, it talks about all the properties of limits. And I've written some of them down here for you. The limit, if you're adding some things, some functions, or subtracting, just means you need to take the limit of each piece and then add or subtract those answers. If you're multiplying, you can take the limit of each of the factors and multiply the answers. Same thing with division. The limit of the quotient is the quotient of the limits. The limit of the product is the product of the limits. The limit of the sum is the sum of the limits, right? This looks complicated, but when you put it into practice, you're really just plugging numbers in and chugging out the answers. Notice that if you have some function raised to a power and you're taking the limit of that, you just take the limit of the function and raise that answer to the power. All of these things are things that you will do intuitively because you've learned to do them already. You just didn't realize what you were doing. The limit as x approaches any number of a constant is always going to be that constant because a constant is not dependent on the value of x. So it doesn't matter what x is approaching, a constant equals a constant. And the limit as x approaches a value of x is that value that x is approaching. You take this guy right here and this guy right here, and you use it in the context of all of these, and you've got everything that you need just about. Okay, some examples. What those properties tell you you can do is that if you have the limit of something, you just plug in the value, chug out the answer, boom, you're done, right? As long as you're not dividing by 0, you are good. Now we saw in the first video that if you plug in those values and you get 0 over 0, it's not just undefined, it's indeterminate. So when you get that, you know that plugging in x equals some number and you get 0 as an answer means that x minus that number was a factor. And if you get 0 on both the top and the bottom, then it was a factor of the top and the bottom. So you factor it out, cancel it, and then you plug in the number again. So for example, if I plug the 0 into this guy right here, I get 0 minus 0 and 0 on the bottom. So I know that I can factor x minus 0, or plain old x, out of both the top and the bottom. So I factor it out of the top, it's there on the bottom, bang, bang, let me write that, bang, cancel, then plug that value that x is approaching into the bit that's left, and you get your answer. Another example, this guy right here, we're plugging a 1 in, square root of 1 is 1, minus 1 is 0. 1 minus 1 is 0. Now I can't really factor this. I could factor this as the square root of x plus 1 and the square root of x minus 1, but that's not right there in your face intuitive, right? So if you see a problem like this, especially if it has a root in it, multiply by the conjugate. If I multiply by the conjugate on the top and multiply by the exact same thing on the bottom, the part on the top gets FOILed out. You multiply these two out, leave the bottom factored just to see what happens because it was the conjugate of the top that you multiplied by, right? So that's what you're going to FOIL. And look, when I FOIL this guy out, I get x minus 1, which is going to cancel with the x minus 1 on the bottom, which leaves me the root of x plus 1 in the bottom. And now I can plug the 1 in. I get 1 plus 1, and I end up with 1 over 2. So try some of those in the homework. You'll see that if you have a root, you just multiply by the conjugate. Simplify it out. You don't have to multiply everything. Only multiply the thing that you've got the conjugates of. And you'll see that stuff cancels. And you know it's going to cancel because you had 0 over 0 in the first place.